Hello everyone, welcome to the Sleepy Universe. Tonight, we drift through a question both poetic and profound. Black holes, could we surf their gravity waves? We'll float through time, bend near horizons, and listen to the quiet breath of space-time itself. So settle in. Let your thoughts slow. Let curiosity wrap you like a blanket of stars. Your journey is beginning. Gently, darkness doesn't scare you here. It wraps around you like deep water, soft and complete. There's no edge to it, no noise, no rush, only quiet that hums just beneath the skin like a low and ancient lullaby. You float in it, not falling, not rising, but suspended. This is where your journey begins. Not in brightness, but in the calm hush of cosmic shadow, far from Earth's busy orbit. Beyond the familiar spin of planets and moons, there are places where the rules we know begin to bend. Here, in the distant reaches of space, light becomes shy and time begins to stretch. There are no landmarks, no glowing suns or sparkling nebulae, only something darker than dark, and somehow more alive because of it. A black hole is not what you might imagine. It does not roar or crackle or reach with grasping claws. It does not chase or burn. Instead, it waits. Quietly, patiently. Not a destroyer, but a presence. A mouth without voice. A body made not of matter, but of gravity made. Dense and deep. So dense that nothing, not even light, can escape. You drift toward it slowly, gently, with a sense of reverence. It is invisible, a hollow where a star once burned, collapsed under its own weight. What remains is not a thing, but a place in space where the curve of gravity is so steep it folds inward, like a well with no bottom. The stars around it spin with subtle unease, bent into curved paths that trace invisible borders, and yet, it's not the fear of falling that you feel. It's curiosity. How can something be there and yet be unseen? You think of it as a shadow, not because it hides in the dark, but because it pulls the light in and does not give it back. A shadow that deepens the more you look at it. And still, you drift closer. Around the black hole is a glowing halo, an accretion disk, a hot swirling ring of matter that spins faster and faster as it approaches the edge. Gas and dust spiral inward like water down a drain, heated to incandescence by motion and friction. This is the only light the black hole allows, not its own, but the echo of what it consumes. You watch this dance from afar, amazed at how beauty and destruction can look so alike. Beyond this bright ring is a place called the event horizon. It's not a surface, not something you could touch. It's a threshold, a point of no return. Once something crosses it, no signal, no particle, no photon can find its way out again. Not because it's trapped in a box, but because the shape of space itself has curved too steeply inward. You imagine this curve like a soft fabric pulled tight by gravity. Most stars and planets create gentle dips. You could walk across them if you were small enough. But a black hole creates a pit so deep and narrow that it has no bottom. Only a vanishing center where the laws of physics break down. This is the singularity, a word scientists use not to define something, but to admit they don't yet understand what waits there. You won't go that far. Not yet. Instead, you circle slowly, gently, feeling the pull not just in your body, but in your thoughts. The black hole doesn't scream for attention. It hums. It invites. It exists without needing to prove itself. You think about how quiet space really is. There is no air to carry sound. no surface to echo against. And yet, if you could hear the black hole, perhaps it would sound like a heartbeat, slow, patient, immense, a reminder that the universe does not hurry, and still it is not empty. This darkness is not absence. It's full of gravity, of possibility, of story. Every black hole was once a star, burning bright, holding fusion at its core. But when the fuel ran out, the balance tipped. The outward push of light and heat gave way to inward collapse, and the star, once radiant, folded in on itself, shrinking, compacting, vanishing from view. You reflect on that, the idea that something so luminous could become something so quiet, and yet still exist, still shape the universe around it. There are many black holes, some small, the size of a city, yet heavier than our sun, some vast, millions of times more massive, resting at the centers of galaxies, including our own. These giants may have formed in the early universe, shaping the growth of stars around them, like stillness shaping motion, and we find them not by seeing them, but by seeing their effects. The way stars orbit strangely, the way light bends, the way space itself seems to ripple when two black holes collide. They are not monsters, they are markers, reminders that the universe is stranger, softer, more flexible than we once believed. As you hover near this one, drifting in silence, you begin to feel a different kind of gravity. Not the pull of the black hole, but the pull of wonder. The way it gently tilts your thoughts toward questions you didn't know you were ready to ask. What happens to time here? What does it mean for light to vanish? Is there something on the other side? And if so, how would we know? You don't need answers tonight. You only need to float in the presence of the question, because this chapter is not about escape or danger. It's about listening to the shape of silence, to the curve of space, to the slow, deep breath of a cosmos. Not in a rush. You are not falling. You are learning to stay still inside something vast, and as you rest in that stillness, you begin to sense something new, not in sight, but in feeling. A shiver, a ripple, as if the very fabric around you is gently stretching. Something is moving, something enormous and far away. A wave is coming, but not of water or wind, a wave in space-time itself. And you wonder, quietly, can we feel what space feels? When it's stirred, the light comes closer, then curves away. Again and again, like a moth circling a flame it can't quite reach. Like a thought trying to land on something it can't fully grasp. You drift near the event horizon, where light itself begins to struggle. It isn't sudden, it isn't violent. It's slow and strange and deeply quiet, a kind of hesitation at the edge of reality. You are not falling, not yet. You are just watching, suspended in the gentle pull of a thing that doesn't let go. The event horizon sounds like a boundary, but it's not something you could touch or see in any normal sense. It isn't a wall or a fence. It's a threshold, defined not by matter, but by time and gravity. Once something crosses it, it cannot return. Not because it's blocked, but because the direction of space and time changes. Inside all paths, even the path light tries to take, curve inward, toward the center. Light moves forward, but the shape of forward no longer points out. You imagine a river flowing toward a waterfall. A leaf on the surface drifts closer to the edge. For a while, it still moves freely, but once it crosses the tipping point, the current becomes absolute. There's no swimming upstream anymore, no pause, no escape. The horizon is like that. Not a visible change, but a shift in possibility. Beyond it, escape velocity exceeds the speed of light, and so nothing, not matter, not energy, not even the information of what went in, can ever return. You watch photons, tiny messengers of light, spiral toward that edge. Some skim close, just close enough to bend and slingshot away. Others are not so lucky, or maybe not so fast. They fall in, not with a scream or a flash, but with a silence so complete it feels like the air has gone out of the universe. But, of course, there is no air here, just vacuum, just curves in space. And yet, there is something beautiful about this place. The horizon glows not from the black hole itself, but from the matter it pulls close, from particles rubbing against one another, heating up as they spiral inward. That disk of swirling material is thin but brilliant, like a spinning halo, and the closer it spins to the edge, the hotter it burns, flaring into X-rays and other forms of light your eyes can't see. It's a paradox. The darkest places in the universe often shine the brightest at their edges. You feel the rhythm of it, the slow circling, the patience of it. This is no hurried storm. It is an ancient process, repeated across galaxies, across eons. Stars wander too close and are pulled in, gas clouds swirl and vanish, and all the while the black hole grows. But what you notice most is that nothing here is violent unless it resists. The danger lies not in presence, but in ignorance. In trying to treat this place like ordinary space, Einstein helped us understand that gravity is not a force pulling at things, but a shape bending around them. Massive objects curve the space around them, and black holes, those densest of all things, curve it so extremely that the shape of space becomes a funnel, a sink, a one-way slope into shadow. It's not that light slows down here. It still travels at its constant speed. It's that the direction light can travel in gets folded inward. You picture this now, not as math, but as movement. A light beam trying to move away, trying to rise, but finding that all paths tilt downward, no matter which way it turns. And then you understand something deeper. To cross the event horizon is not to hit a surface, it's to pass into a region where all motion, all choices, all timelines lead to one place, the center, the singularity. But that's still ahead. For now, you remain on the outside, watching. You're not close enough to fall, but close enough to feel your thoughts being pulled inward. Not pulled away from you, just pulled deeper into themselves, like reflections. In deep water, you think of time now, how clocks behave strangely here. If you watched a friend fall into the black hole, they would appear to slow down. Their movements would stretch. Their signals would shift to redder and redder wavelengths until they faded from view, as if time itself had stopped. But for them, from their perspective, nothing unusual would happen at that moment. They would fall through the horizon unaware. There would be no bump, no flash, just a crossing. And then time would carry them inward in a way we still don't fully understand. This duality, that time behaves differently depending on where you are, is one of the most unsettling and beautiful truths in physics. Time is not an absolute river. It is a landscape, and gravity reshapes it. Near a black hole, time flows differently, more slowly, more stretched. And if the black hole is large enough, the journey inward might even feel gentle. You let that sink in, gentle. That word doesn't often appear in the same sentence as black hole. But here, floating at the edge, you understand it. It's not horror, it's inevitability. And maybe that's why it feels like sleep. the slow drift into something larger than yourself, something beyond conscious control, something that does not demand fear, only surrender. The event horizon isn't a monster's mouth. It's a mirror. It shows us how fragile our assumptions are about direction, about time, about permanence. It shows us that the rules we thought were unbreakable can bend under the right conditions, and maybe, just maybe, it hints at something even more mysterious, because as you hover here, you begin to feel that the black hole is not a void, but a question. A quiet, patient question the universe has been asking since the first star collapsed. What happens to the things we can't see anymore? Do they vanish, or do they change form? Is the information they carried truly gone, or is it hidden, encoded in ways we haven't yet learned to read? You don't need answers tonight. You only need to know that light, which usually reveals, can itself become lost. And in that loss, we find a deeper kind of seeing. You begin to move again, not pulled, but guided, following the path of the photons you watched spiral past. The space around you is starting to stretch in more peculiar ways, and a new kind of silence begins to hum beneath the old one. Ahead, deeper in, something impossibly dense waits without urgency. A place so compact, its very name suggests infinity tucked into a point. And you wonder, as you cross from edge to curve, what does it feel like to approach the heart of a singularity? The deeper you drift, the more the ordinary shapes of space begin to change. There are no straight lines here, no simple directions. What once felt like down is now folded inward. What once meant distance begins to dissolve. It's as if the world itself is curling in on a secret, and you are floating closer to the place where that secret waits. You're not afraid, only still, only aware. The black hole is behind you now, not as a shape you can see, but as a gravity you can feel in your bones. Around you, the very fabric of the universe continues to stretch and bend, folding itself toward something infinitely compact. This is where you begin to sense the singularity, not as a destination, but as a condition. A place where mass becomes pure curvature, where time and space, those twin threads you once thought ran in straight lines, now twist into a spiral so tight they nearly meet. A singularity is not a thing, it's a limit, a whisper where the math loses its shape, where density becomes infinite, and where the rules we use to measure, divide, and define reality stop holding. You imagine holding a spoon in your hand. Imagine filling it not with sugar or soup, but with the weight of Everest, or perhaps the weight of Earth itself. Your hand would vanish. The table beneath it would buckle into nothing. The planet around you would collapse, because that much mass, pressed into so little space, changes the geometry of everything nearby. The singularity is like that, not a mass you can see, but a distortion too sharp to ignore. And yet, it takes up no space at all. It is not wide. It has no edge. It's not even round. It is a point, yes, but a point, not in space, but in our understanding. A place where questions gather and answers dissolve. You float closer still, not with your body, but with your thoughts. Not to define this place, but to dwell in its feeling, to know, at least for a moment, what it means for something to be. Infinitely small and yet overwhelmingly present. Here, time no longer behaves like a river. It doesn't flow, exactly, it falls, it folds. You imagine hours collapsing into seconds, or stretching into lifetimes, depending on your path. And there is no straight path anymore. Every motion, forward, backward, sideways, now leads inward. Every choice points the same way. The singularity is not a place where you stop moving. It is the place where all motion becomes one. And what about gravity? It is no longer just a pull. It is an identity. You are not being pulled by something separate from you. You are being pulled into what you become. Not destruction, but merger. You are moving toward a unity so complete that your individuality, your coordinates, your shape, all fade like ink in water. This isn't a death in the way you've known it. It's not violence, it's silence, a return, a smoothing, a simplification. So deep it erases complexity itself. At least, that's what it feels like. No one has seen the singularity. No one has mapped it. All our equations, all our measurements, fall apart there, not because the place is broken, but because our tools are not yet whole enough to describe it. You wonder if no information can escape. Does that mean everything that falls in is lost? Do stars, atoms, particles, thoughts, even vanish beyond recovery? Or are they woven into the singularity's shape in ways we can't yet detect? Some physicists think the information must still exist, encoded on the edge, like a shadow written in gravity itself. Others believe it is gone, truly gone, a soft erasure written into the nature of black holes. And so the singularity becomes more than just a point of collapse. It becomes a mystery, not just what happens there, but why the universe allows such a place to exist. Why does nature, so orderly in its stars and molecules, allow a place where order itself unravels? You remember now how black holes are born from stars that lived long lives, burning bright, holding back collapse with the pressure of fusion. But even fusion has limits. When the fuel runs out, gravity wins. The star can no longer support itself, and so it implodes, falling inward, layer by layer, until what remains is this, a curved absence, a mouth made of silence, and the singularity is its tongue, buried deep inside, speaking a language no one yet understands. You let yourself feel it, not just as concept, but as sensation. The crushing density, the infinite curve, the slow unraveling. Of time, you feel yourself stretch, not physically, but emotionally, as if your thoughts are being gently pulled apart. You are not losing yourself. You are becoming wide enough to hold more than one truth. The singularity teaches you something. That certainty is not always the highest form of knowledge. Sometimes wonder, sustained, unresolved wonder, is wiser. The black hole does not offer explanations. It offers experience. It offers the soft gravity of curiosity, and you follow it. You drift with it. You imagine what it means to fall forever, never hitting bottom. What it means to be held in place by the shape of spacetime itself, not crushed, not burned, but folded into something smaller and more complete than you can currently imagine. You float there a little longer, letting the idea of infinity settle into you like mist. You begin to realize that infinity isn't loud. It isn't bright, it's quiet, compact, hidden in plain darkness. And it can fit inside something as small as a spoon. Eventually, the shape of the singularity becomes too abstract to hold. Your thoughts drift outward again, back toward the edge, where space is curved but still navigable, where light still flickers, where clocks still try to tick. You feel yourself rising, in a way, not away from the singularity, but into a different kind of depth. A ripple reaches you, not from the center, but from elsewhere, a disturbance in the fabric itself. Something has shifted. Something large, far away, has moved with such weight that its motion sends a wave through space-time, a gravitational wave, and you begin to wonder if space can ripple. Can you learn to ride those ripples? Can you move with the waves of gravity instead of being caught beneath them? What does it feel like to surf a wave not of water, but of reality itself? You float still, suspended in the echo of the singularity's presence. Around you, space holds its breath, but even in silence, something stirs. A motion, faint but deep, begins to pass through you, not through air or light, but through the shape of reality itself. It's not a sound, yet you feel it like a low tone humming under your skin. This is no ordinary movement. This is space-time flexing and relaxing in waves. You are listening to gravity. A gravitational wave does not push or pull in the way wind moves leaves. Instead, it stretches and squeezes the very dimensions in which you exist, not violently, but with rhythm. You feel longer, then shorter, wider, then narrower, but so gently, so impossibly softly, that you might not notice unless you were still, unless you were quiet enough to hear the slow music of mass in motion. It begins, not here, but far away. Two massive objects, perhaps two black holes, orbiting each other like dancers drawn by their own weight, spiral closer and closer, disturbing the fabric of space as they go. Each orbit sends out ripples, like circles, spreading on a still pond, but these circles are not in water. They are in the invisible weave of space-time, and you, floating now, have become part of the pond. The wave reaches you, not with a crash, but with a breath. You barely move, yet everything moves. This is the nature of gravitational waves, not sudden, not flashy. They are subtle, stretching vast distances with only the slightest touch. Their power lies not in noise, but in persistence. You close your eyes or imagine that you do. You don't need to see. You can feel it. The wave passes through your mind like a thought you didn't expect, a pattern shifting your awareness without words. It is as if the universe itself is remembering something, a moment when two enormous beings touched, collapsed, and became one. These waves are old. Some were born before Earth had oceans. Some come from across galaxies. They take billions of years to arrive, gliding through the darkness like quiet messengers. And until recently, we could not hear them at all. But now we do. We have built instruments on Earth, long and careful machines that stretch their arms in opposite directions, measuring tiny shifts in distance, so small that they are less than 1,000th the width of a proton. These machines, like LIGO, listen to space-time the way an ear listens to music, not by force, but by patience. Imagine lying very still on a vast sheet. Someone steps far away, gently bouncing. You don't hear them, but you feel the sheet rise and fall beneath you. That's what LIGO feels. It waits in perfect quiet, tuning itself to the vibrations of the cosmos. And the first time we heard a gravitational wave, it was as if a bell had rung deep inside the sky. Not loud, not sharp, but unmistakable. A warble, a chirp, a faint tremble, the final sigh of two black holes merging. For a moment, space-time itself rang with their union, and we were there to feel it. You think about that, how something so immense could arrive so gently, how the dance of invisible giants could be heard across time. You wonder if the universe is filled with such music, not always violent, not always sudden, but constant and slow. A symphony of masses, weaving waves into space like long, low notes. And you, for a moment, are part of the score. You feel not just the wave, but the harmony behind it, the geometry of motion, the rhythm of mass, the deep choreography of gravity itself. This is not a force applied. It is a shape being remade. You remember how Einstein predicted these waves over a century ago. Not from experiments, but from thought. He imagined how masses curve space, and how moving masses could make that curve ripple outward. He wrote equations, not knowing that one day we would hear the ripples. He trusted the universe would be as elegant as the math. And now we know he was right. But this elegance is not cold. It is not mechanical. It is strangely emotional. There is something about the slowness of these waves, their patience, their reach, that feels like longing, as if the universe aches in motion, stretching out its events like dreams that take light years to unfold. You feel one such wave pass fully through you now. There is no change in light, no blast of wind, only the memory of something vast shifting far away. It's like a thought that brushes the edge of your awareness and disappears before you can name it. And still, it lingers. You drift with it for a while, tracing its direction. It points you outward, toward the source. You imagine what caused it: a merger, a spiral, a collapse. You picture two black holes locked in orbit, circling faster and faster, closer and closer, until they meet. In that moment, a fraction of their mass is transformed into pure wave. Not heat, not light, but gravity made motion. It's astonishing that something with no surface, no solid part, can still move the universe. That gravity, which binds galaxies together and keeps your feet on the ground, can also sing. That mass can vanish, not into silence, but into song. You wonder what it would mean to ride such a wave. Not just feel it pass, but to surf its curve, to follow the rise and fall of spacetime as a kind of current. Could you travel that way? Could you use the natural tides of the cosmos to move? Not through rockets or fuel, but through rhythm. You don't know. No one does. But the question feels warm in your chest, like something not yet real, but already beautiful. For now, you drift. The wave moves on. The space around you settles again, smooth and quiet, like a pond after the ripples fade. And you are still listening, still feeling, but something is changing in your thoughts. You felt the wave pass through you. What if you could see how we listen for them on Earth? What if you could walk beside those quiet machines that stretch their arms to the sky? You turn your mind toward them now, the delicate detectors with laser eyes, waiting in perfect calm to catch the shape of gravity's voice. And you wonder, gently, what kind of instrument is quiet enough to hear the music of the universe? Far from the black hole's pull, far from the silence between stars, there is a place on Earth where people have built a kind of stillness, not in stone or steel, but in light. You find yourself there now, not bodily, but gently placed, as if your thoughts have wandered into the clean, quiet corridors of LIGO, the Laser Interferometer Gravitational Wave Observatory. It doesn't look like much from above. Just long, low arms stretching out in an L shape across fields or desert, pointing like compass needles towards something invisible. But inside, the silence is different. It is not emptiness, it is intention. Here we try to remove every tremble from footsteps, from trucks, from wind, so we can hear what can't be heard. This is a place that listens not with ears, but with lasers. You step inside the thought of it. Two perpendicular arms, each 4 kilometers long, each holding a vacuum so pure that even atoms hesitate. At each end, mirrors rest in suspension, floating on quiet wires, untouched by heat or human breath. And in the center, a laser beam splits, travels down both arms, and returns unless something has changed. If a gravitational wave passes through Earth, it stretches one arm and compresses the other, only a tiny amount, not even enough to move a proton by its own width, but enough for the returning light beams to shift, to interfere, to change the pattern they make when they meet. A dance of dark and light fringes, a rhythm too fine for eyes, but not for instruments. You imagine the light bouncing forward and back, again and again, caught between mirrors, building up its sensitivity, like a whisper echoed until it becomes a song. And you marvel not at the technology alone, but at the quietness of thought that made it possible to even think this might work. Someone had to believe that the universe whispers its events in waves, and now we've heard them. In 2015, the first signal arrived, a faint ripple lasting just a second, but so distinct, so exact, that it told a story. Two black holes, far away, had spiraled into one. Their mass, their speed, their final breath, all written into that tiny stretch of space. It didn't make a sound in the air, but in the fabric of spacetime, it rang. Since then, others have followed. We have heard neutron stars colliding. We have heard black holes dancing. We've begun to map the universe, not just with telescopes, but with these new ears. Gravity waves don't scatter like light. They pass through galaxies unchanged. They are messengers that do not forget. And so, these long-armed machines become our instruments. We tune them like flutes. We silence them like temples. We place them far apart, one in Louisiana, another in Washington, others across the world. Not to isolate, but to compare. When two or more detectors hear the same ripple, at the same moment, we know it's real. We triangulate. We begin to point. But more than pointing, we begin to understand. Gravitational waves don't just show us collisions. They let us glimpse the very structure of space-time. They reveal what happens when the universe moves its heaviest pieces, when mass accelerates, when time curves, when the invisible becomes rhythm. You step out of the hallway in your mind and look at the sky. You imagine the whole Earth as part of this instrument, not just a detector, but a listening shell. You see that we are floating in a sea of slow vibrations, that every moment, even this one, is passing through waves older than our planet. You think of the light in your own body, the subtle gravity of your own mass, the way the molecules inside you move, all these to make ripples, small, too small to detect, but real. You are not just listening to the universe, you are part of the music, and yet the quiet of these machines is humbling. They remind us how small the signals can be, how much care it takes to detect what matters. In a world of noise and rush, these detectors are still. They ask us to wait, to listen, to believe that meaning arrives not in volume, but in vibration, and you begin to see the story forming. First, the singularity, then its waves, then our attempt to listen. Each chapter not replacing the last, but unfolding from it, like echoes returning from the deep. So what's next? You turn the thought slowly, like a leaf on water. If we can now hear gravity, could we ever use it? Could we shape it, ride it, or one day travel with it? Not with rockets, not with metal, but with timing, with rhythm, with a map of curves, written in gravitational lines. And that's when the next question forms in you, gentle, persistent. What would it take to surf spacetime? It begins as a feeling, not speed, not thrust, but timing. A perfect alignment between your own motion and the breathing rhythm of the universe. The wave comes, and instead of resisting it, you lean in. You don't push forward. You fall with it, like a leaf on a current that knows the way. To surf a gravitational wave is not to race, it is to become part of the movement. To move not through space, but with space itself. You are not alone in wondering this. Physicists, too, have asked, if spacetime can ripple, can we use those ripples to go somewhere, to ride them like surfers riding ocean swells? It's not a fantasy. It's a question rooted in the very shape of gravity. In general relativity, motion is a response to curvature. Objects follow the path that takes the least resistance, not a straight line, but a geodesic, the natural flow line of curved space. If a gravitational wave passes by, that path gently shifts. So what if you were already moving, falling freely, and the wave passed through? Could it push you, even slightly, toward another place? Could you time your motion to amplify the wave's effect, catching just enough curvature to be carried farther, faster, smoother? The challenge, of course, is scale. Gravitational waves are vast in reach, but faint in effect. Their stretching and squeezing are smaller than atoms, and most pass through matter without resistance. But in principle, the idea remains. Spacetime itself is not fixed. It moves, it pulses. And if you could match that pulse, perhaps you could move with it. You close your eyes and picture a spacecraft, not a rocket blazing fire, but a patient vessel tuned like an instrument. Inside, nothing rattles. Outside, no thrusters ignite. Instead, it waits for a passing wave. When one comes, the ship adjusts its internal mass, slightly shifting weight, changing alignment so it falls just a little differently along the curve. You are no longer pushing against gravity. You are obeying it. You are finding the shapes where motion becomes effortless. A kind of gravitational sailing. This is not yet a technology. It's not even a plan. But it's a vision, a direction of thought that says, what if movement wasn't about power, but precision? What if traveling great distances required not energy, but harmony? You think again of how we travel now. Brute force, combustion, thrust. We fight inertia. We fight mass. But surfing gravity would mean something else, something quieter, more intimate. You would travel not above the universe, but inside its movement. And this movement is everywhere. Space-time is always shifting. Not just from black holes colliding, but from the mass of everything, everywhere. Planets curve, space, stars bend it. Even you, even now, cause tiny ripples. Your body has mass. Mass shapes space. Space shapes motion, and motion is time. So perhaps the first step toward surfing space-time is learning to feel its shape, not with your skin, but with your awareness. To notice where gravity pulls, not harder, but smoother. To feel where your path can align with the soft descent of space-time's own motion. You imagine now being near a strong wave source. Two neutron stars spiral toward collision. The gravitational waves they release pulse outward in smooth arcs. You're not in their path, not directly, but nearby. As each wave passes, it stretches space, then releases it. You time your motion just right. Each time the wave stretches outward, you move forward. When it contracts, you slow. A resonance builds. Your path amplifies the rhythm. You are not stealing energy. You are flowing in sync. A surfer does not create the wave. They shape their body to ride it. And here, in space-time, you do the same. Not with limbs, but with mass, position, and timing. And the beauty is, there's no resistance. Gravitational waves don't scatter. They don't weaken like light. They pass through everything, clean, untouchable. If you could learn their music, you could ride them like starlight rides the void. Of course, the scales are enormous. The waves we can detect are rare and large. They require cosmic events, black hole mergers, neutron-star collisions. But smaller waves surely exist too, all around us, too soft to measure. Perhaps one day, technology will grow sensitive enough to tune into those subtle tides. Perhaps one day, motion will become less about fuel and more about form. You think now of birds gliding on thermals, lifting without flapping, of whales following sound currents across oceans, of leaves spiraling in river eddies. Nature already teaches us, when you move with the medium, you save energy. When you ride the wave, you become part of the wave. And so, the idea lingers. Not science fiction, not fantasy, just a patient wondering, a question shaped by physics and cradled by dreams. Could we, someday, build vessels that no longer push, but listen, that no longer resist, but dance? Could motion in the future be less like a rocket and more like a song? For now, it is only imagination. But imagination, too, is a kind of vehicle. It carries us into futures not yet born, into shapes not yet carved by metal or light. And your imagination now carries you onward, not just along the wave, but toward the next question. If we could surf space-time, where would we go? What lies beyond the black hole's pull, in the places where time itself bends backward? You feel a softness return to the silence. You are still, but not stopped, and gently you begin to drift toward the strange possibility of time travel. You rest now on the edge of time itself, where clocks tick slower and the future feels like it's waiting in a room just next door. The black hole behind you doesn't move, yet everything around it does, falling, spiraling, stretching, not toward destruction, but toward a different shape of time. Here, minutes stretch into hours, seconds thicken like syrup. The closer you drift to the event horizon, the more time loosens its grip on consistency. You feel it in your breath, though breath is only metaphor now. You feel it in the quiet unfolding of awareness, how a thought takes longer to rise but stays longer. Once arrived, outside this well of gravity, a century might pass while you hover here, unchanged. The universe rushes on, but you are suspended, a stone in the stream. This is real. We've seen it, measured it. Time runs slower in gravity's arms. It's not a trick. It's not perspective. It's woven into space-time itself. Clocks on mountaintops run faster than clocks at sea level. GPS satellites must adjust for this, or their signals drift. And near a black hole, this stretching becomes more than inconvenience. It becomes a door, and so the question rises. Not abruptly, but like mist lifting from a field. If gravity can bend time, could it bend it into a loop? In physics, we call this a closed time-like curve, a path through space-time that returns to its own beginning. It's not magic, it's geometry. Imagine walking in a circle through space. Now imagine doing the same in time. The math allows it under strange conditions, and black holes, with their extreme curves and warps, might just allow the shapes that make it possible. One such shape is called a rotating black hole, a Kerr black hole. Unlike the simple silent ones, these spin and their spin drags spacetime around with them like water caught in a whirlpool. This dragging might, in theory, twist time so tightly that a loop could form. A path you could travel that leads you not just forward, but back. You float closer to the idea, not into the singularity, but into the swirling region around it, where motion feels inevitable. You don't fall straight in. You orbit endlessly. And perhaps, with the right velocity, the right angle, you could return to where you began, not just in place, but in moment. It's dizzying, but not in the way of fear, more like awe. Because the rules here are not broken, just widened. Time, once thought to be a single arrow, now reveals itself as something softer, something that can bend, and maybe, just maybe, curve into itself. But what would it feel like to travel a loop in time? Would you meet yourself, or become the version of you who once waited? Would the past remain fixed, or would it shift like a dream remembered too late? No one knows. And yet, the questions are real, studied, modeled. The equations allow the possibility, though they also raise warnings. These loops could allow paradoxes, could cause causality to unravel, could mean a future causes its past, which then causes its future. And so physics pauses, not at impossibility, but at uncertainty. Still, you let yourself imagine, not the grand, cinematic leaps, but the quiet ones. A moment you return to, not to change, but to re-feel. A sunset you drift through twice, a kindness repeated, a breath that lingers. Time travel, not as conquest, but as presence. You think now of the structure of space-time, not flat, but curved, like fabric laid over hills and valleys. What if a deep enough valley folds the fabric back on itself, not just in space, but in duration? A fold where one end meets the other, and motion along that fold carries you back. You are not falling backward. You are gliding forward along a path that happens to return, like a clock hand that circles, not because it defies time, but because it follows it faithfully. But these are delicate shapes. They may require energies we cannot yet produce. They may collapse before we enter them, or they may exist only in theory, beautiful, complete, but unreachable, and yet they hold something beyond speculation. They hold the hint that time is not what it seems. Even now, in this drifting silence, you feel it. Time is not ticking, it's unfolding. Not like dominoes falling, but like petals opening, each layer revealing the next, and maybe, if curved, just right, folding gently back to the start. And you wonder, is the future truly ahead? Or is it beside us, above us, curled inside us? Time travel may never be easy. It may never be possible. But the very idea that time is flexible, that it can loop and bend, changes how you understand being alive. You are not just moving through time, you are made of it. Your memories are threads, your hopes extensions, your heartbeat a rhythm counting the curve. So you rest now near the edge of this possibility, not trying to build machines, not trying to prove or disprove, just listening, just letting the shape of time settle into you like a lullaby without an ending. And as you drift, a softer thought begins to take hold. What if memory itself is a kind of time travel? What if you've already returned through the quiet places, where gravity, emotion, and time meet in dreams? You open your thoughts to the wider sky now, not the one filled with stars, but the invisible field of motion that binds them. It is quiet, yes, but not without tension. You've drifted with waves. You've felt time stretch like breath. But as you imagine what it means to build, to explore, to move through these vast cosmic seas, another feeling begins to stir. Not fear, but reverence. Because space is not empty, it is filled with potential, and all potential carries risk. You are not in danger, not here, not now. But the question gently rises. What if we misstep? What if we aim wrong? What if something small, a miscalculation, a fragment, a forgotten force, grows large across the distance? Even asteroid mining, once a hopeful seed in your imagination, carries the weight of responsibility. You think of those chunks of metal and stone floating in slow arcs between planets. Some the size of houses, some the size of cities. Many hold water, iron, even rare metals, riches unclaimed, drifting silent in sunlight. But bring one close to Earth, and that same promise becomes a puzzle. How do you guide it, slow it, hold it steady? How do you ensure it never veers? You imagine a team of minds, scientists, engineers, navigators, their hands not on controls, but on equations. They calculate trajectories with infinite care. They simulate gravity assists, solar winds, thermal tugs. Every move is mapped with caution, because in space, small forces matter. A pebble's push can, over months, become a mountain's shove. These planners are the quiet sentinels of our expansion. You don't often see them, but their work surrounds every spacecraft, every orbit, every close flyby. They track near-Earth objects like astronomers watching the breath of giants. And when a rock wanders too near, they raise gentle alarms, not to panic, but to prepare. Because sometimes the sky does send reminders. The flash over Chelyabinsk in 2013. A fragment only 20 meters wide, burst with the energy of atomic fire. No one had seen it coming. Windows shattered, people fell, and the Earth, indifferent, kept turning. Other stories lie deeper in time. The Great Chicxulub impact, 66 million years ago. The asteroid that changed everything, that ended species, and made room for others. That rock was perhaps 10 kilometers wide, a cosmic whisper, yet loud enough to reshape life, so we watch. Not in fear, but in diligence. We chart orbits, we scan the dark, we build models of what might happen, where things might go, and slowly we begin to design defense. Not weapons, but nudges. Missions like DART, where a small spacecraft purposefully collided with an asteroid's moonlet, shifting its path just slightly. It was a test, a proof, a soft promise that we could change fate just a little. If we act in time, you think of this now, how the future depends not only on ambition, but on caution. The more we reach into space, the more we must carry the weight of foresight. To bring an asteroid home for its metals or water is bold, but it must be done with care. Orbits must be stable, approaches must be slow, gravity must be respected. One wrong tug, and what begins as progress could become danger. And yet, this doesn't frighten you, it humbles you. Because to face the universe's vastness and still take responsibility, that is a beautiful kind of bravery. To mine the sky and still bow to its forces, to build and still listen. Risk is not failure. Risk is the edge where learning begins, the boundary between the known and the possible. And in space, that boundary is always moving. You imagine standing in a control room years from now, eyes on a screen as a captured asteroid gently enters orbit, not falling, not threatening, but arriving like a guest, carefully guided. You picture the months of planning, the deep math, the quiet hands at keyboards. No celebration yet, only the soft breath of something gone right. We do not need to fear the cosmos, but we must never ignore its rules. Physics does not forgive. It simply follows its path. And so we must follow ours with care, with both wonder and wisdom. And in this balance, you find peace. You drift through these thoughts like a feather in airless stillness, feeling the gravity of caution, the lift of vision. Every mission is a question, every orbit a prayer turn. So now, as you float between ideas, you see something forming on the horizon. Not danger, but design. You wonder, what if we went further? What if, someday, we built not just ships, but homes among the asteroids? Not to harvest, but to live. What would it feel like to anchor your life to a rock that drifts between Mars and Jupiter? To wake under strange sunrises, in low gravity, with Earth only a point of light, and gently, without urgency, you begin to imagine such a life, one where the quiet of space becomes not exile, but belonging, where risk is never gone, but always met with grace, where the next chapter isn't just about watching asteroids, but about building among them. Somewhere in the slow paths between planets, a stone turns. It's not a planet, not a moon, just a rock, dark, cold, ancient. But tonight, you drift closer to it, and as you approach, you begin to see something different. There are lights, soft, pulsing glows tucked into its craters, like stars fallen. Inward, this is no longer just an asteroid. It's a home. The thought begins as wonder, but quickly becomes detail. You imagine descending to its surface, your feet landing with a gentle press, as if you weigh less than a whisper, and you do. Gravity here is shy, a fraction of Earth's tug. You float between steps. The body becomes buoyant. The breath deepens. Time feels like it loosens. Your shelter is carved directly into the rock, not concrete, not plastic, but regolith sculpted into smooth, layered walls. Inside, radiation is filtered. Temperature is tamed. There are gardens here, lit by filtered. Sunlight bounced through mirrors, not greenhouses as we know them, but slow, spiraling biomes where plants adapt to the sway of low gravity. You walk through one now. Roots are shallower, leaves curl differently. Water moves in beads that glide like pearls through the air. There's no rain, but there is moisture, fogs that drift and feed. Crops grow slower, but cleaner. Insects buzz in lazy spirals. The air smells like basil and iron. You run your fingers along the walls. Behind them, hidden systems recycle heat, air, and water. Everything moves in loops. Life here must close its circuits. Waste becomes resource. Every breath is accounted for, and yet it doesn't feel like scarcity. It feels like care. You wonder who lives here. Scientists, perhaps, or settlers, or artists drawn to silence. People who chose this stone not for what it lacks, but for what it makes possible. Space to think, to build, to redefine what a home can be. Out your window, a circle of reinforced crystal, the stars move slowly. Jupiter glows on the horizon, pale and enormous. Beyond it, a black canvas pricked with unblinking lights. You think of Earth now, distant and small, not forgotten, but framed. Like a candle in a vast cathedral, you adjust to this new rhythm. Days are artificial, defined, not by sunrises, but by the pulse of station lights and scheduled sleep. Work is quieter, time stretches, even conversation changes, fewer words, more pauses. You learn to listen to silences, to what is not said. You learn to wait, and gravity, always, is different. Your muscles work gently, bones adapt, exercise becomes a floating dance. You learn new forms of movement, tools are lighter, laughter lasts longer, and dreams feel more vivid, as if your mind, untethered by weight, floats deeper. You think of children growing up here. Their games are different, their bodies taller, limbs looser. They think of down as a direction, not a force. Earth is not a memory, but a story. They belong not to continents, but to motion. This isn't a colony. That word feels too sharp. This is a beginning. A hollow rock, yes, but filled now with warmth, with intention. What once drifted in silence now carries songs, footsteps, sleep. You begin to see the asteroid belt differently. Not a junkyard, but an archipelago. A chain of quiet islands, each with potential, some hollowed for habitation, others reserved for growing food, collecting ice, or serving as rest stops for longer journeys. A slow, deliberate scattering of life, and perhaps, someday, more than just humans. Perhaps our ecosystems travel to bees, fungi, microbiomes. Perhaps we send not just machines, but relationships. Every rock becomes a page in a shared story. Of course, challenges remain. Radiation, resource limits, the long ache of isolation. But none of them feel insurmountable. Here, technology walks hand in hand with rhythm, not rushing, not conquering, but adapting, listening, and you. You realize you don't feel like a visitor anymore. You feel like someone who could stay, who could learn the slow rotations, who could find peace in the hum of generators, the garden fogs, the unfamiliar constellations. Because, in some way, this is what it means to live in space. Not to escape Earth, but to carry its best lessons, balance, care, community, into the void, to build new homes with old values, to expand not just outward, but inward, toward quieter, slower ways of being. And now, as you rest once more, a new thought floats up like morning mist. What if these homes are only the beginning? What if we could craft not just life among rocks, but entire worlds of our own? You've wandered through invisible tides, followed the curve of light into silence, and found yourself where questions outlast answers. Black holes will keep spinning, time will keep stretching, and your mind, your soft, curious mind, has touched a little more of the universe tonight. Thank you for dreaming with us. Good night from the sleepy universe. Let the stars keep watch as you drift.